In our previous part, we have considered the voltage of our EMD over here, and while finding out, we have got this is our last equation that I have shown you in our previous part. Now, quite naturally, you can understand that the current is not IAMD. Is we need to find out this current, the current through our small p resistor over here. We need to find out that current over here. Then how do you get to that current over here? You do know that we have got another resistor which is been Q, that is been present over here. And according to the current division rule, we do know that as the current is flowing in this way, after this point M, the current has divided into two parts. You can see the current has divided into two parts. Now, what is the definition for our current division rule? If you do follow our previous videos, you will do get understand that analogy over here. Say we have got our two current, the two resistor over here, and what is the definition for our current division rule? According to our current division rule, we have got, say we need to find out the current I1. So what is the value for our current I1? The opposite resistor, which is this one, the opposite resistor divided by our total resistor R1 plus R2 multiplied by our total current, which is our I. Similarly, for our another branch through our resistor R2, what is the current? Once again, the same formulation, the resistor R1 divided by R1 plus R2 multiplied by our total current. So this is our current division rule. If you do follow our circuit theory classes, you will do get to that understanding over here. Now, why do I mention the current division rule over here? Because we are going to utilize that current division rule in this present context. Okay. Now you can see that after this point small m, the path has divided into two paths, and our ultimate aim is to find out the current through our small p resistor over here, because that is the current for our IAMD. Now, what is the ruling over here? The opposite resistor, you can see that the opposite resistor is small r, because small p and small q are connected in series, and that series connection is been placed parallelly with our small r over here. So if you do consider the current is flowing in this path, do follow my hand please. This portion is very important. If the current is flowing in this path, then what is going to be the opposite resistor for this condition? The opposite resistor will be small r, and the total resistor for our consideration is the summation of these three resistor parts. So this small p, small q and small r over here. Now what is the definition for our IAMD, or what is the exact expression for our IAMD? The opposite resistor, which is small r, divided by our total resistor for this overall path. So what are the total resistor factor we have got? Small p, small q and small r. Small p, small q plus small r multiplied by our total current. So which one is our total current? The total current is bigger I. So this is our expression for our IAMD over here, and we need to put that expression over here to get the voltage expression for our EMD over here. I want to repeat over here once again. First, we have drawn the circuit or that part of that drawing over here, and our ultimate focus is to find out the voltage EMD, because in our previous part we have already got the EAB over there. So this is the expression over here, and how do I reach to that expression? Please do follow our videos for every minute, every second, because for our video or for my point of view, every second or every minutes are very important for our engineering brother classes. That is why I keep on telling you the same thing. Don't skip our videos, or don't start our videos, or don't follow our videos from the middle part of our consideration. Okay. Now I want to repeat over here. In our previous part, we have got the voltage as EMD as this one, but you can feel that the IAMD, we need to find out that IAMD expression over here. So we have simply applied the current division rule over here. And what is the current division rule? If the current is flowing in this way, always to consider the opposite resistor divided by, in the numerator portion, the opposite resistor path will be there, and in the denominator, the summation of our total resistor path for that consideration will be utilized, multiplied by our total current over here. And I have utilized, just by utilizing that expression we have got, this is our expression for our IAMD over here. So now the next step is quite naturally the simplest one. We need to put the expression for our IAMD in this given expression over here, and finally we have got the EAMD. That is our main objective. So let us do put that over here. So what is ultimately the EAMD? The EAMD is our IR plus the expression of IAMD is this one. So small r divided by P plus Q plus R multiplied by our I and multiplied by small p. Because of this small p, we can say that the small p is being present over here. So if you, this portion is not been required, as we have already utilized that portion over here, so I can erase this portion. Now ultimately, what is the final expression that we have got? The final expression is I bigger R plus our small p divided by P plus Q plus R multiplied by our I. Is not it the same one? Now if you do take the common of I, we have got the R plus small p divided by P plus Q plus R. So this is our expression for our EAMD over here. In our next part, we will do equate this EAB and EAMD over here, and what is the exact objective for that one, we have already considered that over here or in our present condition. So I'm just going to give you some amount of time to think about this current division path and how do I reach to that IMD over here. And I have just replaced that portion over here, and I have just shown you how to get to that consideration over here. So this is the best classes that will be very important for your Kelvin Double Bridge over here, and I have shown you all the parts because that is the most important part over here. The concepts are absolutely crystal clear over here, and you can understand that how do I reach to that consideration or how do I reach to that expression over here. In our next step, we will do equate this EAB and EAMD over here. But before I go into that, I want to give you some amount of time to think about this exact diagram and the current division rule over here. In our previous part, we have got the EAMD over here, and we have already got the EAB expression over here. So without wasting any time, let us do equate these two voltage expressions over there, and let us see what will be the considered expression after that. I think you have got this understanding over here. So let us do consider our analogy over here. So our next objective is quite naturally to equate these two voltage parameters over here. First of all, EAB, which is our EAMD. First, I will write these two expressions over here, and after that, I will do erase these two expressions over. So EAB is our this one, P divided by P plus Q multiplied by our I. Inside our bracket, I do have R plus S plus our small p plus small q multiplied by R divided by P plus Q plus R. This is our expression for our EAB, which is equal with our EAMD. EAMD is this one, which is I multiplied by our R plus small p divided by R divided by our P plus Q plus R. Okay, let us do check that. P divided by P plus Q multiplied by I, R plus S plus P plus Q multiplied by R divided by P plus Q plus R, which is equal with our I multiplied by R plus RP divided by P plus Q plus R. Okay, these two expressions are absolutely correct. We need to equate that over here, and let us do raise to that balanced equations for our Kelvin double bridge over here. How to reach that? I am just going to show you all the part over here. So this I will eliminate, and I can write this equation as P divided by P plus Q, which is equal with our, I will do transfer this portion to the another side of our expression, which is R plus our small r P divided by our P plus Q plus R divided by this whole thing, which is R plus S plus, I will do separately write this portion if we do multiply that portion over here, which is small pr divided by P plus Q plus R plus our small qr divided by P plus Q plus R. Okay, I can write this expression just like this one, which is P plus Q divided by P. So this lower portion will become, the denominator will become the numerator over here. We have altered the ratio of our P plus Q divided by P. So definitely we will do alter this another side of our ratio as well. So let us do that over here. So in order to do that, I should say the R plus S plus our R small p divided by small p plus small q plus small r plus R q divided by small p plus small q plus small r divided by this portion, which is R plus our R small p divided by P plus Q plus R. So we have just interchanged our ratio over here, and you can see that we have done that. Now let us do play with our given relation over here. So to play with, we should erase our previous lines over here. So at the final stage, we do have, this is our ratio. So I can, after this step, I can write this expression as this one, as P by P plus our Q by P and I can write this expression as this one, as r plus, I should take this one as small r small p divided by r plus p plus q, this one. Okay, now r plus q divided by small p plus small q plus small r, and I should write this r at the next part of our addition. That will be much more better for you, or to understand in a lot more better way. Okay, and I should take that out, and I should consider that plus s plus our small r q divided by small p small q plus small r divided by this portion over here. So we have separated that portion for your advantage factor over here, which is r plus our small r small p divided by small p small q plus small r. Okay, now we should follow up the ratio over here. So I should erase these two steps. Now ultimately these p will cancel each other. In our left hand side we do have 1 plus q by p, and I can write this ratio as this one, r plus smaller small p divided by this one, r plus smaller p divided by small p small q small r, and this one divided by our r plus the upper portion, which is small r p divided by p plus q plus r divided by this portion, which is r plus small r p divided by p plus q plus r plus s plus r q divided by p plus q plus r. This one should be our r, divided by this one divided by the same one, which is r plus smaller p divided by p plus q plus r. Okay, so we have we can write that if you do add these two expression as the you will get the previous expression over here. So quite naturally, and this will be eliminated. Okay, and what will be the next step? The next step will be this one, 1 plus q by p, which is this one is 1 plus our s plus smaller q divided by our r plus smaller p divided by p plus q plus r. So ultimately this 1 will be eliminated, and finally we have got this expression over here. So let us do further simplify over here. So to do with, or to consider that, we should eliminate our previous two expressions over here. Finally we do have these expressions over here. Okay, now let us do cross multiply over here. And how do you cross multiply that? The simpler one, if you do consider that, finally we do have this one, which is q by p, which is equal to s plus small r q divided by our r plus our small r p divided by our p plus q plus r. Okay, now we should cross multiply the expressions over here. Now you can see, if you do cross multiply that, we do have qr plus q small r p divided by p plus q plus r. For the another side we do have ps plus I think we have missed a portion over here, which is small r by q divided by small p plus small q plus small r. Okay. So for that one, we do have the p ultimately small r q divided by small p plus small q plus small r. Okay. This will be our formation. Now, for the next part, what is the analogy? We are trying to find out the unknown resistor for our R over here. So we need to transfer that rest of the portion to the another side of our equation. We do have PS plus P R small q divided by P plus Q plus R minus our Q RP divided by P plus Q plus R. Now finally we can do transfer the Q to the another side of our expression. What is the expression? The expression will be unknown resistor R, which is PS divided by Q, plus this one is P by Q, this one is RQ divided by P plus Q plus R, this one is minus Q by Q RP divided by P plus Q plus R. Now you can do relate with our previous part of our analogy over here. Now if you do take the common of RQ divided by P plus Q plus R, you will do get our previous analogy over here. So what is the first statement over here? I want to repeat over here. Once again, we have forgotten the lower part of our analogy over here, which is AS. I want to say over here the ratio should be this one, which is AS plus small rq divided by small p plus small q plus small r. So that is a little bit mistake from my part, and I have rectified that analogy over here while cross multiplying our analogy over here. The best part of our analogy is please do this type of expression just by your own hands. That will be much more better for you to understand in a lot more valuable way. So let us do find out the unknown resistor, or finally what is the expression that we have got. Finally, if you do take the common over here, what is the unknown resistor? The unknown resistor R, which is equal to our PS divided by Q. Now if you do take the common of our this factor, which is RQ divided by P plus Q plus R, and what is been present inside our bracket, the present factor will be P by Q minus of our small p divided by Q over here. The same expression just like our star delta method or star delta analogy over here, and just by utilizing our conventional method we have shown you how to consider or how to have the Kelvin double bridge expression over here. Now how do you get to that? If you do multiply these as RQ divided by P plus Q plus R, you will do get this portion, and this QQ will be actually this QQ will be eliminated, and you can see that if you do multiply that QQ will be eliminated, and small p divided by our small p plus small q plus small r will be present for that condition. So if you do multiply these two factors, we do have this last expression, this expression over here. You can do understand that. Now we have considered that for our Kelvin double bridge, we have taken that the ratio of our P divided by Q, which is equal with our small p by small q over here. Now if you do say that the condition that should have been considered as bigger P by bigger Q, which is small p by small q over here. If you do put this relation over here, we have got this will be eliminated, so 0 multiplied with this factor will become 0. So what is the final expression? If you do say this condition should have been fulfilled, then ultimately the unknown resistor is finally the PS divided by Q, and what we have considered accordingly, we can say that the lead resistor of small r is ineffective for our formulation over here. And how do I say that? Because if you do consider or do set the lead resistor small r value as small as possible, then we can eliminate or do neglect this part of our expression. We have got another sort of ideas or path to neglect this expression over here, just by considering the ratio just like this one. If you do put that, this will become 0, so 0 multiplied with this one will become 0, and finally the unknown resistor is Ps divided by Q, which is equal with our Winston bridge analogy over here. So this is the complete picture of our Kelvin double bridge, and I have shown you all the parts, all the cards in a lot more sequential way. So I want to repeat over here once again. At the start of our consideration, we have started the introduction of our low resistor measurement. For the next class, we have considered the introduction for our Kelvin bridge, and for the next part we have considered the how to balance or how to make the balance of our Kelvin bridge over there. And most importantly, why don't we consider the Kelvin bridge connection over here? Because the connection is not perfect or not in a practical way, or we cannot make that connection in a practical way. So for the next part, we have separately considered the star delta formulation methodology to show you how to reach to that balanced condition for our Kelvin double bridge. And finally, we have considered the best consideration for our conventional method to show you the same equation over here, and we have got the expression as this one. That is why I keep on saying you that no other YouTube channel will show you this type of detailed analogies over here, and I am just showing you all the cards over here, and I have shown you two different ways to consider or to have the balanced condition for our Kelvin bridge. So my ultimate verdict is this is the best YouTube channel for educational purpose. Okay. So finally, I have completed the Kelvin double bridge over here. Do subscribe, do like our videos, and do share our content, and keep following our classes. That's it. Thank you and goodbye. If you like my video, so what are you waiting for? Please do subscribe my channel, hit the bell icon for more updates, and stay tuned to the channel. Thank you and goodbye.